Hello, welcome everyone to our interoperability webinar about our message envelope. The message envelope is a universal API for conversational assistance, and I think when you see our demonstration and our discussion, you'll see how that works, and you'll appreciate that idea. The presentation is by the Open Voice Network Architecture Work Group. I'll be your moderator today. I'm Deborah Dahl from Conversational Technologies, and we have three speakers: David Attwater from TalkMap, Emma Coyne from EdgeTalk, and Alan Wiley from Man-Made Web Limited. And I hope you'll find this a valuable experience. I'm looking forward to your comments. Next slide, please. Today's webinar is sponsored by the Linux Foundation. It'll be it'll take place according to their rules. It's being recorded. It'll end on time. Next slide, please. So today's webinar is going to be an overview, as I said, of the Universal API for Conversational Assistance. We call this the message envelope. It's going to build on our earlier webinars from March 22nd and June 15th. And I have the links to those webinars if you'd like to go back and take a look at them later on. We're going to, in addition to overviewing our draft spec, we're going to be demonstrating the spec in action with three independently developed conversational assistants interoperating to meet the user's goals. And then we'll have a tour of our GitHub repositories if you're interested in looking at our code or contributing to our code or sample implementations. We're very excited about getting some feedback from everyone. So what we're going to do is we'll conclude the webinar with a Q&A session. And what we're going to do is if you have a comment or question or something that you'd like to bring up, please put that in the Zoom Q&A, not the chat, but feel free to use the chat for your communications, general comments or communications among each other. But we'll just be addressing questions in the Q&A during the Q&A session. So let's go to the next slide, please. The Open Voice Network is a nonprofit vendor-neutral community of the Linux Foundation. We have two major initiatives. One is Voice that Works Like the Web, and the other one is Voice Worthy of User Trust. And today we'll be focusing on our initiative, the progress on Voice that Works Like the Web. We can go to the next slide. The general idea of a universal API for conversational assistance is a kind of scenario where some kind of assistant realizes that the user's question is outside of its expertise. It then, using OVON standards, identifies another assistant that might be able to answer the question, contacts the other assistant using the OVON standard API, which is message envelope plus dialog events. It conveys the user's question and any conversational history that's needed to the other assistant, and then enables the other assistant to continue the conversation. And we're going to show that today, as I said, with our three systems. And just to give you some idea of the next steps in this work, we're going to show some more applications of our standards. One is going to be use of the standards by the Estonian Information Services bureaucrat system. And we'll have another demonstration later on of an OVON open source sandbox implementation that we're working on now and will pretty soon be in GitHub. So we can go to the next slide. So our next topic is, let's get into it. It's the OVON message envelope. This will be presented by David Attwater from TalkMap.
Good afternoon. My name's David Attwater from TalkMap. Can I take the next slide, please? I'm going to spend the next few minutes just talking you through the latest step forward that we've been making as a working group on building interoperable standards for conversational assistants. And that's, as Debbie has mentioned, the message envelope. The purpose of the message envelope is, imagine you're a conversational assistant publisher. So you have a conversational assistant. It could be an extremely general one, like Alexa or one of the extremely general ones, or it could be an extremely specific one if you're a government department, or whether you're an enterprise that's trying to provide conversational services on very specific, carefully curated information. The question is, how do you publish that bot so that it's essentially universally available? It might be living within a particular ecosystem, but you don't want it to have to stay within that ecosystem. You want it to also be accessible from other ecosystems, and also accessible by referral from other bots, as Debbie has mentioned. So what we've worked on is a simple standard, which we're calling the message envelope, which allows you to publish a public API around your conversational assistant that can do some of the basic features that I'm going to show you on the next slide. Okay, so your conversational assistant, in order to be able to interoperate with other systems, and also through other ecosystems and channels, it needs to be able to do the things that we see on the screen. First of all, it needs to be able to accept invitations to join in with a conversation. So if another agent or another assistant browser or channel wants to draw your agent in, you need to be able to accept the invitation. Secondly, then, of course, it needs to be able to actually hold conversation with the users or potentially other agents. And thirdly, when it's done its job, it needs to be able to pass control back off, either to the referring agent or to somewhere else that it thinks is appropriate to help it solve the problem. So in order to achieve that, we have at the moment 4 basic message types. We have the assistant engaged message, which is essentially an invite to join in with a conversation. We have the whisper utterance, which is it's like an ordinary utterance, but it's actually a back channel between one agent and another, whispering what it is that is required of it at this moment. So, for example, could you please do this? Or the user just said that. So it's a way of essentially passing immediate task requests from one agent to another in the transfer of control. Then we have utterances. Utterances look the same whether they're coming out of your assistant or into your assistant. We draw very little distinction between the direction that utterances are passing in the standard. And then we reach the stage where you want to pass control, and that will be done by essentially a delegation, either back to the agent that originally referred into you, or maybe off to somewhere else. And of course, at that delegation, you'll see we're joining into assistant engaged with another agent and passing a whisper utterance on. So let's look at that in a little bit more detail. Next slide, please. In our white paper, we've identified 3 different patterns of interoperability, and we have channeling, delegation, and mediation, and they're all very similar, but I want to focus specifically on delegation today, and that's the pattern that I'm going to show you now in a little bit more detail. So I want to imagine we've got our user on the left here. They're using some kind of device. It's, you as a provider of a bot probably don't care or don't want to know the intimate details of that channel. There's an assistant browser which essentially provides a media interface to that particular channel, whether it be a chat channel or a vocal channel or a mobile phone, telephone interface, speech services and TTS services, and potentially things like wake words. So there may be really rudimentary dialog facilities in here, but very little. So our user, next click please. A user will engage with the browser, and essentially let's assume this is a wake-up pattern. So they'll say something like, "Hey Bob, our browser has got rudimentary capabilities to know that that's associated with personal host assistant A on the right here, and will send an engaged message. Next click, please. So the assistant gauge is enough for your agent through the universal API to say, okay, I don't know what it is that they want, so I'm just going to greet them. And the assistant browser then will appropriately render that up in the particular media channel to the user and ask how they can help. Next click, please. So now we have the user present some kind of request. In the way that we envisage the standard working at the moment, there will always be an assistant that's essentially in focal control. So the personal host assistant at the top here is in focal control, not the assistant browser. Their message essentially gets passed through, it gets rendered through to the host assistant, and they asked to check their credit card balance. Now let's assume that this is a general personal assistant like Cassandra that you're going to see, or like Alexa or Google Home, but it knows that it's not itself capable of providing credit card balance services, but it does know the identity of the user, and it also knows their credentials. So it decides to do an onward referral. So next click, please. So there's a few things that happen here. From a dialogue point of view, we've still got things to say. We've got to manage the discourse management to essentially announce that we're passing them over to someone else. So we have an utterance, which is the sure, let me pass you over to Acme, the Acme Bank. Then we're using the standard messages of a delegation. And then at this point, the host assistant is going to pass a whisper event. Essentially, it's like a hidden utterance that is passing through. That may be just the user utterance, or it could be a reformulation of the user utterance that's come from the host assistant that's going to get passed through. The assistant browser has a very simple job to do at this moment, which is just handle the delegation and bring in the other agents. So if we can click the message, please. The next click. So you'll see the assistant browser has rendered the sure, here's the Acme out to the user because that's an utterance. And then it's made a request into the bank assistant to engage, and it's passing the whisper utterance. So as part of the standard, the bank assistant can choose whether to accept or not. And in the current standard, we're always accepting, but we envisage that will become richer as the standard moves forward. And that bank can engage, and it already knows the task that's been asked of it. And let's assume for the time being that we've solved some of the issues of context and passing on authentication information. That will be something we'll talk about in later webinars. And next clip, please. We then have the assistant is able to then be in control and present this utterance back to the user. So in this instantiation, we'll see various patterns. First of all, there's this assistant browser that we can think of as a media gateway through to the user. It has essentially maintained the channel with the user and has got rudimentary control and synchronization features, but doesn't have really any intelligence in it in terms of understanding the tasks. We see that initially a general personal assistant has been brought in and put in control of the conversation, and then it has essentially handed the baton over to a specific assistant. And then that specific assistant, when it's done, will then render control to either back to the personal host assistant, will be the most likely pattern, or it could pass the baton on to another subservice that it wants to engage. So the dialogue message envelope consists of these messages we see on the right here: the assistant engage, the utterances, the delegate, and the whisper utterances. There's 4 different types. They're wrapped up in a single envelope. We're not presuming any protocol currently, but we are in the demo. You'll be seeing us running this under HTTPS, and we envisage that this will be the first instantiation of the use of the envelope in the protocol. So that's just an introduction to the function of the message envelope. I'd like to pass over now to Emmett, who's going to give a practical demonstration and show you some examples. We have the next slide, please.
Yes.
For Emmett.
Hello. we're doing this actual demonstration of the stuff that David talked about and that Debbie hinted at. So next slide. This demo is, as Debbie said, going to be, and David too, 3 independently developed assistants solely using the OVON messages. There you will see a primary assistant, Cassandra, and that was developed by my company, EdgeTalk. There'll be a general purpose assistant that will give the general answers, a GPT-like large language model provided by David's company, Man-Made Web. And then there will be a specific assistant that will answer a specific question about something that relates to me that was developed by Conversational Technologies under Debbie. So next slide. That's generally what you're going to see, but please remember, we are not demonstrating assistant functionality. They're very simple assistants. It's not what they do, but how they communicate. And we are showing how assistants interoperate using OVON. Remember, they only exchange OVON standard messages. There are no other protocols or calls between them, just these envelopes with events inside. All 3 assistants are developed by different development teams. There is no communication between the teams other than what messages, the OVON messages, would be sent. They're all 3, interestingly, all written in different programming languages, and they are all running on different services around the internet. So there is no inter-platform communication of any kind. They are just using OVON. So with that, I think we can go to the screen sharing, and I will, it says I can't share the screen. Hold on, there we go. I will share the screen. And I think we're ready. Is that showing? I think it is. Okay. So here we are with this prototype of this playground that was invented for our demos. I'm going to begin the conversation.
Cassandra here. Welcome to the multi-agent demo.
So this is my primary assistant, Cassandra. That's the first assistant David mentioned at the top of his slide. She's going to talk to me about things. I'm going to ask her some questions. First of all, I'll ask her a very general question and see how she handles that. Can you tell me the reason why tire rotation is important?
I am not an expert on tires, but I will ask our general AI assistant to help.
Tire rotation is the practice of moving tires from one position on a vehicle to another to ensure even wear and tear. It helps to extend the life of the tires and improve overall vehicle performance.
Hello again. Just out of curiosity, did you get what you needed?
Yes, that was excellent.
Wonderful. I'll pass it along to the agent.
So what
now?
So what happened was I asked a very general question. Cassandra received that question, knew she couldn't answer it. And the mechanisms of how she analyzed it are not important, but she decided she would pass it on to a general agent for assistant for answering. She passed it on to this wizard that answered the question, and it was a pretty good answer. But now I really want to know something about my particular car and its rotation. So I might ask her, is it time for my rotation on my car?
Okay. I will connect with your preferred auto maintenance shop to see what their records show.
Hi, this is OVON Auto Service. Yes, your Subaru Outback is due for a tire rotation.
Hello again. Just out of curiosity, did you get what you needed?
So the question, my personal assistant knew that I was asking about my car. It knew that I had a preferred maintenance, auto maintenance company that I went to. It had my credentials and passed it along. And the specific assistant at OVON Auto could answer my question very directly. And that's kind of what happened here. Let's take a look in more detail in a sequence diagram. Show me the sequence diagram.
Here you go.
So if you've seen previous demos, you realize that this is a sequence diagram, and each vertical column represents a participant in the conversation you just heard. The red-blooded human, that's me. The assistant browser, that's gray, it symbolizes it's sort of neutral. It doesn't really do anything other than connect these things, and it does the ASR, the speech recognition, and the speech synthesis. There's Cassandra, who we woke her up, and she sent an OVON utterance message in the envelope back to the browser. It unpackaged it and rendered her speech. Cassandra here, welcome, blah, blah. I said, then a question, can you tell me the reason, in general question, reason why tire is important, tire rotation? The client, the browser did the recognition, packaged up an utterance in the envelope, an utterance event. It sent it to Cassandra, who did she did whatever she does to understand the meaning of that. She decided that she would say, hand it off, and she would also, she would say she would hand it off. She would also send an engage message to the assistant she's handing it off to. So goes back to the browser, the client renders, this thing renders it. I'm not an expert on tires, blah, blah, blah. It makes a new connection. It then sends the assistant engage off to this wizard. It initializes, does whatever it does. We don't know. It's a separate entity unto itself. It decides that it's going to do a single utterance. So it packages up an utterance event, and it also packages up an assistant engage to send it back to where it came from, to Cassandra. So that thing is unpacked back in the assistant browser. The text is rendered, all that general stuff about saving wear and tear, blah, blah, blah. Then after it completes that, it takes this assistant engage and it actually does it and it sends it back to Cassandra again in an OVON envelope. Cassandra replies, and this goes back and forth. So hello again, out of curiosity, excellent, and yeah, I'm sorry about it. She gets a little chatty there sometimes, so she was happy, I guess, that it worked. But this will continue until I ask another question that she decides she has to engage another assistant with. So I asked specifically about my car and tire rotation, and so that's when her natural language understanding or dialogue management decided who to send it to. And so she said, okay, I'll connect you, blah, blah. Connects to this column, which is OVON auto. It initializes, it's got that whisper message that it knows what the question is, it knows it's me. It packages up an OVON message that envelope that it is now rendered. Hi, this is the auto service. Yes, your Subaru is due. And this goes on. It then engages Cassandra again. She asks how it went. And I said the sequence diagram. That's what happened. So I think this is the overview of how we expect this to work. It's pretty simple. In our architecture, it's moderated by the assistant browser, and all the messages are handled there and passed on to the appropriate assistants. In this model, all of the speech recognition and synthesis is done here, and it's directly on a device that the human has access to. So I'm going to release my screen now, and then we can go to the next slide. This is a picture of what an actual envelope looks like for this demo. As David said, we are refining and improving it, so don't take this as detailed gospel, but this is the overall picture. There's an OVON wrapper at the top, you can see, and it includes all of these things, which it has important things like the things in yellow. conversation ID. This single conversation, even though it involves multiple assistants, will have a continuous thread going through it. It is one conversation. There are events, and that's, you heard David and me mention the events. There's an assistant engage in this particular example, and it says, how do I engage with this particular assistant? And these are the parameters it uses. There's also a whisper utterance. Cassandra took the question and turned it into something that was more like a large language model prompt, and sent this off to the wizard. The wizard then came back with a nicely formed 50-word or less explanation of why tire rotation is important. So that gives you a view of the underpinnings and how it works. I think that sums it up for me. So. So.
Okay, so I just want to make a couple of comments about what we were just looking at. We saw first a generic assistant, which was developed by Alan's company, and then an enterprise assistant, which was developed by my company. We saw both of those cooperating, and it's interesting that there's a role for both in a conversational interaction. The generic GPT-3 assistant uses a large language model to answer general questions, and it knows about, I'm sure everybody knows this, it can answer general questions about almost any topic, and that includes general auto maintenance. But the enterprise assistant has an account and knows about you. It knows about your car, knows about its maintenance history. So it could, besides telling you that you need a tire rotation, it can make appointments potentially, tell you about any open recalls on your car, remind you to pay your bill, or even upsell and encourage you to trade in your car. The large language model can't do that because it doesn't know about you and it doesn't know about your car. So we saw in the demo how the different kinds of assistants can cooperate to address the user's goals. We can go to the next slide. The next slide is an introduction to our interoperability GitHub repositories. So the specifications are under very active development and shared repositories in GitHub. They're very much works in progress, but here they are. You're invited to explore. The first one is Lib Interop, which is where we have our specifications. We have some preliminary Python and JavaScript libraries for working with our dialog events and possibly with our message envelopes, or that'll be soon. And most importantly, really, if you want to understand where we are with the specifications, we have sample messages in JSON and YAML, primarily in JSON, that show the messages that you've just seen in the demo. That's the URL for the Lib Interop repository. Our second repository that you might be interested in is called Implementation Examples. And those are several sample assistants using different technologies for the core assistant, such as Amazon Lex, GPT-3, and WebSockets. And those are in the Implementation Examples repository. If you get a chance to take a look at them and make clone the repositories, make pull requests, and give us any feedback that you have on the code and the examples, that's very welcome. So with that, I would like to move on to the Q&A session. And I think we have a couple of questions in the Q&A.
We do, Debbie. We have two questions. One is from Janice Mandel. Thank you, Janice. She asks, how does governance work in this environment?
Okay. Does anybody want to take that on?
No, no one wants to take it on.
Maybe that's TBD.
Yeah, we're very conscious of issues around confidentiality, security, etc. And we have not tackled them yet. I think it'd be fair to say. As you'll know, there's an alternative working group within OVON working on essentially standards for all of these things, and we will anticipate taking all of those things into account as we move the protocols forward. But I think it's fair to say, unless the other team members have got anything to add, that at the moment we're focusing primarily on the functional aspects of dialogue intercommunication, but are painfully aware that some of these governance issues are going to have to be addressed.
I think it has to work first, and then we make it safe. I think that's how they started cars, right?
Yeah, they haven't really finished that job either, have they?
No, never will.
So another question that we had that looks really interesting is, are there any thoughts on message failure and retry? That's a really interesting topic. You know, has anybody got something to say about that?
Well, we've talked about several things that can happen with, for instance, if an assistant just doesn't answer. Clearly, there's standard things like with timeouts that could happen, but you don't want to operate with timeouts because the conversation doesn't really go on hold for 5 seconds until you say, whoops, nobody's there. There are errors that an assistant could decide, well, I'm too busy right now, and it might respond. That's not technically an error, but it's, you can't assume the assistant will take over when you engage them. We have given thought to that, but that's not in our current spec at this point, how to manage moving on to another assistant if necessary. But we are thinking about it.
We have another question here from an anonymous attendee who asks, does this universal API take away from the need for other APIs within conversational assistance?
No. This is an API for interoperation between the conversational assistants. The assistants themselves may use other APIs to do, intent processing or looking up data or all sorts of other APIs. This is a specific API for interoperation between assistants.
Nathan, did you have? Sorry, go ahead,
Go
David.
ahead,
Oh.
I was going to say that we're picturing possibly two situations as well. At the moment, pretty much every conversational assistant will have essentially a native media interface or host browser, as we're calling it. That will operate in one of two ways. Either your assistant will actually have two interfaces. It will have its interface to its native. So let's say, for example, you've got your interface to Amazon, who, let's say, in the first instance might not be supporting OVON, and then you might choose as an agent to also publish yourself as an OVON interface, in which case your agent is taking upon itself to satisfy the interoperability. Or quite likely moving forward, the host browsers themselves we would hope, will start adopting the interoperable standard internally and using that as the primary mechanism to engage with an agent, in which case it will matter less what your host sort of infrastructure is. So in that sense, I think we can see things running in parallel for some time.
We have another question from Michael McTeer. Michael asks, thank you, Michael. How does Cassandra know which agent can answer a question? Some systems have a ranking system to choose between available agents.
Hi, Michael. Thanks for the question. That whole issue is something we're calling discovery. I mean, we're modeling this interconnection assistants, much like web pages link to other web pages, but also there's search engines in the web. We do need, and this is not by any means complete. Cassandra did not go and look up something and do that. We just knew for the demo she would go to the generalist and to the specific. But a discovery system that would say, do you have a system that can answer this question? We imagine that as kind of an API where you would pass something off, or maybe it's a specialized assistant. You say, can you handle this utterance? And it says, no, but these three might. And that's part of our, we expect that to be part of our system moving forward.
Part of our philosophy is that increasingly agents should manage their communication with other services through natural language itself. So we're envisaging, for example, the discovery service could itself just be another agent that our agent uses a whisper utterance to say, you know, can you find me someone who can do X? And then that will be a specialist agent who may never actually talk to an end user at all. They may just be providing services to other agents. So we're kind of hoping that an ecosystem will develop to naturally have discovery emerging using natural language as one of the primary mechanisms.
Here's another great question from an attendee who asks, what value is this to my company's IVR system? Does that mean that someone using Alexa or Google Home could connect to our corporate IVR? In other words, to go outside the firewall.
Yeah, I think that's true. The thing that has to happen is for there to be some kind of a connection between Alexa or Google Home to the IVR through OVON specifications, and we'll provide the specifications, but the Amazon or Google has to provide the ability for their systems to create OVON messages, and whoever is hosting the IVR has to enable it to understand OVON messages. But there, in theory, that should not be, there's no technical reason that can't happen.
And then we have a question from another attendee who asks, will this universal API enable conversational assistants to tap into language models of all types and sizes?
That would be a good question for Alan, if you'd like to talk about that, since you implemented the LLM assistant.
You have to unmute, Alan.
Okay, there's no reason why you can't have multiple assistants within a car. Your master, your main host, would know which specialist agent to talk to find out something. You could be looking up for road conditions, roadworks, weather, traffic. Each of those could be provided by a specialist assistant. And we've done things like that already, using a voice call from a car, from a mobile, and we can talk to an assistant that then talks to other assistants using the OVON standard message.
We also had another question about the large language models. Will this universal API enable conversational assistants to tap into language models of all types and sizes?
I don't think that's reasonable. The general model which you saw today has an OVON face interface, talking to other OVON agents, but it also has an interface to OpenAI's DaVinci model. And it uses, of course, OpenAI's protocol and OpenAI's API. So it translates from one API into the other. And I don't think we will various applications from people like AWS, OpenAI, Azure, and so forth will have specialist APIs. And I don't think we could really expect them to stick to use the OVON API.
But someone could, as you did, write a wrapper around it, and that assistant then uses the large language model behind it. There's nothing stopping many people from doing that with different models.
I think we need to draw a distinction between large language models that are being used as dialogue systems and the underlying technology of large language models. It's extremely likely that almost every assistant in the world in 5, or even 2 years is going to be running a large language model of some kind inside it, because it's just an obviously useful technology for any assistant to use. But we draw a distinction between that and what we might call conversational systems like ChatGPT, for example. There are, in fact, themselves dialogue systems, in which case they're behaving very much like any of the assistants that you've seen today. And there's no reason at all why OpenAI or any provider in the world who has such a general purpose large language model chat system couldn't just wrap it up in OVON and make it public through an OVON interface, or not, as Alan was addressing. But they could all interoperate in the way that we described today.
Here's another question. This may take us in a bit of a different direction. An attendee asks, can you tell us more about the work with Estonia? What are they using? Debbie, would you like to take that?
Yeah, that's a great question. It's a really exciting project that we've been working with. The government Estonia Information Systems Authority is a very advanced digital information system for citizens of Estonia. The system that I believe there's many assistants. The one that we're working with is interoperable system called Bureaucrat. I think it has about 20 or so assistants that users can access. So the idea is that the users will have access to any government services through one portal that coordinates all the bureaucrats. It can provide information. So the Estonian government wanted to use standards for all these bureaucrats to cooperate with each other, and so we started working with them. We have an active project where our goal is to have the bureaucrats communicating with each other using OVON messages. We've been working on this for about a month, but it's going well, and I think we'll have a demo pretty soon.
I believe we're about at time, so if we want to just wrap this up, probably. Thank you all for participating. Debbie, would you like to close this up?
Yeah, I think it's been great. I'm really happy that you were all able to spend the time, and I would encourage you to. I think we have some more slides, just with some follow-up information. How you can participate. You can volunteer to work on use cases and specifications and implementations too. And we're very happy to get any kind of feedback that you have. And then there's one more. Okay.
There's a quick question about the sandbox. You might want to say we are working on a place where you can make demos sort of like this and play with the messages with little servers and assistant browsers and hook them up to your own code or do what you want with them. So that's coming at the beginning of the year.
Okay, thanks everybody. See you next time.